The question given here is a block of mass 0.5 kg hanging from a vertical spring executes simple harmonic motion of amplitude 0.1 meters and time period is given as 0.314 seconds. Find the maximum force exerted by the spring on the block. So here first let us draw the system here. This is a vertically hanging spring. So let us assume the spring constant is K and the mass of the block which is given for us, let us take it as M. Let us assume this is the natural length of the spring and this is the mean position. So at the mean position, let us assume the expansion in the spring as x0. Now it is oscillating about its mean position. Let us assume this is the upper extreme position and this is the lower extreme position. You can see here when the body is at lower extreme position, the expansion in the spring will be maximum and the force exerted by the spring will be also maximum. So let us assume this amplitude of oscillation as A, right? Now let us write down the information given in the question, which is mass of the block, which is 0.5 kg. Similarly, amplitude of oscillation is given, which is 0.1 meters, and time period is given as 0.314 seconds. In terms of pi, if you want to write it, this will be is equals to pi by 10 seconds. So first I am going to use the relation between angular frequency and time period, which is omega is equals to 2 pi by t. Here I am going to substitute the value of t, which is pi by 10. So this will be 2 pi divided by pi by 10. 10 will come to the numerator. This pi will get cancelled out. So this will be is equals to 20 radians per second. So omega is calculated now. Now let us calculate this x0 value. At mean position, the net force should be equal to 0. If you see the forces acting on the block at the mean position, mg will be acting in downward direction and the spring force, which will be equal to kx0, will be acting in upward direction. As the net force at mean position should be 0, we can write kx0 is equal to mg, which implies x0 will be is equals to mg by k here. We know all the values, m value, g value, and let us calculate the k value before substituting here. The force constant or spring constant in spring block system can be written as m omega square. As we know, omega will be is equal to root k by m for spring block systems. Now mass is 0.5, which is half, into omega square. Omega is 20, so omega square will be is equals to 400. So here the k value is 200 Newton per meter. So let us use this k value here. So x0 will be is equals to mg, which is 0.5 into 10 divided by 200. So this is 5 by 200, which will be 0.025 meters. Now when the spring is at its lower extreme at this position, the expansion is going to be maximum, and maximum expansion here is going to be x0 plus a. We know the value of x0, we know the value of a, just substitute here. So 0.1 plus 0.025, which will be is equals to 0.125 meters, which implies the maximum force applied F max will be is equals to k into maximum extension, which is x0 plus a, which is already calculated. We know the k value, we know the x0 plus a value here, just substitute it. Here the k value is 200 and x0 plus a value is 0.125. So this will be is equals to 25 newtons. This will be the solution for this question. Thank you.